Hello out there dear friends, and welcome once more to this video. Today we have in this video friends, we shall be looking at the question you can see I have here on screen. Friends, I took this question from the AQA textbook. It was a paper 1 question. As you can see, the answers have been given here. So friends, you know, as the MCQ presents itself, guys, you have to answer the question before you see the option that corresponds to the answer you have, before you can tick it off. So friends, please, if you're new to this channel, don't forget to hit that subscribe button and press the bell icon to get notified each time we upload new content, and please give the video a like because that does motivate keep producing more great content for you guys. Let's dive straight into our video today. Awesome friends, awesome. As you can see friends, the question reads that a wire of length capital L and diameter small d is fixed at each end and placed under tension T. At this point, the frequency of its first harmonic, that is its fundamental frequency, is small f. State which of the alternatives, that is from A to D, gives the density of the material of the wire. Great. So friends, they've given us the options. As you can see, we have here. So friends, let's start by trying to picture out what the scenario looks like, guys. So let's have our wire of this form. Since they said it has length L, so let's indicate the length. So the wire definitely has a length. We can call that capital L, and it has a diameter, guys. This is the diameter of the wire. That is diameter. We can call it small d. Good. Then friends, they want us to derive an expression for the density of this wire in terms of the tension, the diameter, the frequency, and the length of the wire. So friends, now if you don't know the concept that you ought to use in order to come up with this formula, guys, it will become very difficult for you to start, okay? Because the starting point actually matters a lot. If your starting point is wrong, guys, you're not going to arrive at the answer so well, okay? So friends, in this case, our starting point, guys, we are going to be starting with the formula that we know fully well as far as waves are concerned, right? That C is given as the square root of T over mu. Okay, now guys, you know that in physics, okay, in physics, formulas are very useless once the symbols have not been defined, okay? Because if you just write this formula somewhere, somebody might be saying that this C means capacitance, why this T can mean something else, this mu can be talking about the permeability of free space or permittivity and so on and so forth, guys. So symbols in physics must be defined such that you can give meaning to all those symbols. Quite good. So first, in this case, we are going to tell him that where T is a tension force on the wire, and guys, we would also tell them that our mu is a mass per unit length of the wire. It is sometimes referred to as a linear density of the wire. Great. Then friends, we will tell them that our C is simply the wave speed, because once this wire has been subjected to a tension force, guys, it is going to produce some amount of waves, okay, some amount of waves, and we are going to use that property now to get the density of this wire because it has been subjected to tension, okay, tension at both ends. So we are going to get an expression for the density of the wire. Great. So friends, if we square both sides of this our equation, guys, if we square both sides, we are going to be having our C squared equal to T over mu. Great. Then friends, we should keep in mind too well that I said that our mu stands for what, guys? Mu is what? The mass per unit length. That therefore means that we can tell that our mu in this case is equal to capital M over L. But friends, what is capital M? We must define it because we know what this our mu stands for and what this our L stands for, because we've indicated here as the length, and this mu here we said it was the mass per unit length of the wire. So we must tell them what this capital M represents. So we'll tell them that this our capital M is simply what, guys? The mass of the wire. Great. Once we've defined it, guys, we are free to go ahead now and use our formula. Good. So friends, in this case now, we'll also tell them that the speed of a wave is related to its frequency and wavelength by the equation C equal to F lambda. Good, great. We have C equal to F lambda. But guys, we must tell them what this lambda means, okay? Because we know what C means, that is the speed of the wave, Then guys, this f is a frequency, that's a fundamental frequency. Then our lambda, guys, we must tell them that this our lambda is simply going to be the wavelength of the waves produced in the wire. Great, that's super important, guys, super important. So friends, please don't forget to like the video, friends. Press the like button, that goes a long way to motivate me, guys, to keep producing more great content for you. Thank you very much, guys. So friends, from this our equation c squared equal to t over mu. What is our c, guys? Our c in this case is what? F lambda. So plugging everything, guys, we are going to have f squared lambda squared equal to, now guys, our t stays the same, then our mu is given as what, guys? M over L. So flipping everything, guys, we are going to have our f squared lambda squared equal to TL over M. Great. Because we divide the denominator by M over L, the L simply goes up. Okay, that's why we have our T to be L over M. Great. So friends, we should also know that, don't forget that our rho is given as what? M over V. Guys, this our rho is simply going to be what? The density of the wire. Okay, remember that we must define every symbol we use. We must define every symbol. Friends, I am solving this question for the case of if this question can come under the structural section, where you have to show them qualitatively how you got the expression that we are about to get now. But if it's for the MCQ sake, no need to be defining all these symbols. You have to rather get an expression for the formula very fast and tick your answer, guys, since time may not be on your side. Great. So friends, we also have to tell them what this V represents. We will tell them that this V is simply going to be what? The volume of the wire. Great, that's good. But friends, we know that the volume of the wire V is given as what? Pi times the diameter squared L over 4. Okay, because guys, this our wire has the shape of a cylinder, right? It's cylindrical, so it has the shape of a cylinder, and the volume of a cylinder is simply given as pi radius squared times the height. Our height in this case is the length. Our radius, guys, is simply what? Our radius is simply what, guys? Is 2 times the diameter, right? Great. That therefore implies our diameter, guys, is simply going to be what? Our radius, guys, is simply going to be 2 times the diameter. So, and if we replace everything, since our diameter on 2, that's the diameter divided by 2 is simply the radius, right? So if you square that, we are going to have our diameter squared over 4 to be the radius squared. Great. That's why we have the volume V to be pi d squared L over 4. Good. So friends, we have all of these because these are the instruments, these are the tools that we are going to use to come out with an expression for the density. Great. Friends, we should also note that guys, the length of the first harmonic, guys, is half of the wavelength. Okay, it occurs when the first harmonic, guys, occurs when the length of the wave produced, guys, is simply what? Or where the distance between the note and a successive note, guys, is the same like what? Half of the wavelength. Great. So first, let's picture out what the situation looks like. Let's just picture it out. This is what we have. Wait, this is what we have, guys. This is, at this point, guys, we can name this as our node. We have capital N. This is also a node. Great. That's the lowest point on a wave. Okay, it is a node. Then, guys, this highest point is the antinode. So no need to name it. We all know it. Great. So at this point, guys, this is the node, and we know that the distance between two successive nodes, guys, is simply going to be what? Half of the wavelength. Great. So we can tell them that the length of this our waves, that is from the node to the node, guys, is simply equal to what, guys? Half of the wavelength. Good. So we now have the length L to be the same like what? Lambda over 2. If you solve for lambda, guys, we are going to have our lambda to be the same like 2L. Good. That's what we have, guys. So if we put our lambda, guys, into this our equation, if we substitute everything, guys, and our M, if we make M the subject, we are going to have our M to be the same like what, guys? Rho times V. Okay, so plugging everything, guys, we're going to have F squared into 2L. Since our lambda is equal to 2L, we have 2L that squared equal to, we have our TL says the same, all out of our rho V. Good. That's what we have, guys. That's what we have. So friends, if we cross multiply all through, we are going to have rho V to be the same like what, guys? over 4L F squared. Keep in mind, friends, that there's one L here, right, and there are two of them here, so we are going to cancel one of them. That's why we no longer have the L here. Great, that's just what we have. Then, friends, we should know that at this point in time, guys, we can replace V by its value. Okay, keep in mind that the V is simply the volume of the wire. So if we replace everything by its value, guys, we are going to have raw. We are going to have raw, which is the density, because we have to solve for raw, since raw is the density in this case, into our volume is simply going to be pi times the d squared L over 4. That is equal to T over 4L F squared. Great. So first, at this point in time now, we notice that we have a 4 on the right hand side and 4 on the left hand side, right? We have a 4 on the right hand side, 4 on the left hand side. They can cancel, and the guys simplifying everything is going to give us our raw to be the same like T over pi d squared F squared L squared. Great. So guys, that's the answer we have. That's what we have. So we can recognize that it is not A, guys, it is not B, it is not C, right? But it is not B, sorry, but it is C. Great. So we can therefore strike that answer, that this is our answer. C is good. Okay, great. So friends, that's how we can answer this question. I hope you found it useful, guys. Do put in the comment section down below if you found it useful, guys. If there's something you understand as well, guys, comment section down below, and I'm going to explain further as soon as possible, guys. Thank you very much for watching the video. And friends, I want to draw your attention to something. Okay, now guys, in this question you can see that there are so many important concepts that you need to know. In the first place, guys, you must have to know this formula that C is given as the square root of T over mu. Okay, this is very important, guys. You must have to know it because it's very important. It is this formula that led us to answer this question. Had it been you don't know this formula, guys, it would be so difficult to figure out what this our expression could die down to. Good. So you need to know this formula so well, guys. Also this one as well, also that the length of the distance from this node to this other node, guys, has to be the same like half of the wavelength. Okay, half of the wavelength. So this point as well is also very important, also very important. Good. So you need to know it, because if you just replace your length by L, you're rather going to have this as your answer, which is not correct. This is rather your answer and not this. Good. So friends, thank you so much, guys. Make sure you subscribe to the channel so that you can have access to all our great contents, guys. This is good for those who are taking the medicine school, those who are taking engineering concourse in general, those taking their science examinations. It is good for them. Thank you very much, guys, and see you in my next video. Stay safe, guys, and